Okay, so in this video I'm going to go through amides and the amide bond formation. So amides can be prepared when we have a carboxylic acid and an amine, such as ammonia, that are then heated together and they form this new amide bond here. So this is very much a simplification of the actual mechanism that occurs, but for our purposes this is fine. So we have here carboxylic acid, and I've got the OH group there shown in red, plus one of the hydrogens from ammonia. So these atoms here will form a molecule of water, and we have a new bond being formed from the nitrogen of the amine through to this carbonyl carbon. So there's our new bond being formed there. So this is now an amide. We've got this nitrogen connected to the carbon double bond oxygen. So that's how an amide is formed. So new bond from the nitrogen of the amine through to the carbonyl carbon. Amides can be hydrolyzed in under acidic or basic conditions, and the products are slightly different depending upon whether it's acid hydrolysis or base hydrolysis. So first one we'll go through is acid hydrolysis. So we've got our amide here being hydrolyzed. So we've got a molecule of water and the acid there, in this case hydrochloric acid. So if they react together, heat it up, then this amide bond here is hydrolyzed. So we get a carboxylic acid and an ammonium salt. So this is like the reverse of the amide bond formation. So we've got a carboxylic acid here, and then rather than an amine, this is just the salt of an amine. So this is the ammonium salt. In this case it is ammonium chloride because the acid we used was hydrochloric acid. So we've got carboxylic acid and then the ammonium salt. With base hydrolysis, so again our amide, this time it's reacting with base, so sodium hydroxide is a strong base. Heat it up and we get a carboxylic acid, but in the form of the sodium salt. So we have this sodium carboxylate salt. So this is it's a carboxylic acid, but under basic pH it loses that proton and forms the sodium salt. So we've got a sodium carboxylate and we have ammonia or an amine. So under basic pH, then the amine is in the form of the amine, as opposed to the acidic pH where it's in the form of the ammonium salt. And under basic pH we get the carboxylate salt, whereas in acidic pH it is in the form of the carboxylic acid. But this is really the reverse of that previous slide. So we have a carboxylic acid plus an amine to give an amide. So the reverse of that, we would have an amide being hydrolyzed to give a carboxylic acid and an amine, and then their forms there just depend upon what the pH is. So acidic pH we get these forms here, carboxylic acid and ammonium salt. Under basic pH we get the carboxylate salt and the amine. So this then is relevant for amino acids when they form peptides. So an amino acid general formula is shown here. So we have the central carbon here that has 4 groups attached to it. So it has a carboxylic acid group, it has an amine, it has a hydrogen, and it has an R group. And each of the amino acids vary by this R group. So within each amino acid there is an amino group and an acid group, hence the name amino acid. So when amino acids react together, they form an amide. So this is the same reaction that we saw before. We've got a carboxylic acid from one amino acid plus the amine from another amino acid. So these will then react together, form a molecule of water, and then we have this amide bond being formed here. So I see a lot of students try and join these together through the R groups. So these amino acids don't connect through the R groups. They form through this amide linkage being formed here. So through the loss of water, we then form this amide linkage in here. So we could then build up a chain of amino acids linked together to form a polypeptide. So it's not through the R groups, we form these amide bonds in this extending peptide chain.